Hi students, good morning. Today we are in the second class of our online virtual lab. In the previous period we have discussed many things what all are there in the science lab. Today also in this introduction section we are discussing about some of the materials present in the science lab. Now we can start with the chemistry. Now we can see what all are the materials required for a chemical reaction. Here you can see different instruments that we used for doing a chemical reaction. So you can see different reagents in different bottles and different instruments, that is made, most of the materials are made up of glass, that is borosilicate glass, which is used to make lab materials. So we can start with a common instrument we use to do a chemical reaction, which is a test tube. Okay, this test tube is used to do a chemical reaction. So we can pour whatever the material we use to do a reaction, we can pour that in this test tube, and with this we can do a chemical reaction. Okay, next one we can learn about another one which is also just like a test tube. Here you can see the name of this one, it is borosilicate, made up of borosilicate glass. Okay, so it is known as boiling tube. If we want to boil something, we can use this boiling tube. Okay, next one, it is a beaker. It is 100 ml. Here you can see, here also name is there, made up of borosilicate glass, 100 ml beaker. So measurement is here. Okay, we can measure the amount of liquid or whatever it is with this beaker, which is called a glass beaker. Okay, and another type of beaker is this one, it is 250 ml beaker. It is also used to measure chemicals, to do a chemical reaction. And the next one, 500 ml beaker, that is also there for doing a chemical reaction. If we want to heat something, we normally use 500 ml beaker or 250 ml beaker to do the reaction. And now here it is a dish, china dish. Its name is china dish. Made up of, it is made up of a clay dish, we can say. It is also used to do chemical reactions, or if we want to heat something, we can use this. And the next one, another one, which is a conical flask. From the name itself, it is there conical, it is just like a cone, that is why it is known as conical flask. This is also for titrations. Titrations means reactions. There we are using a conical flask. We can titrate like this by moving the conical flask like this, and we can do the reaction. And the next one here, it is a round bottom flask. So there also name is there, round bottom, RB flask. Its bottom is just like a round, that is why it is called a round bottom flask. And the another one, it is known as thistle funnel. If we want to filter something, we can use keep a filter paper here, and we can keep it like this, and then we can pour materials inside this funnel to filter. That is the use of thistle funnel. And the next one, here you can see a glass rod. If we want to mix something, when we do a chemical reaction, if we want to mix something, we can mix like this. For that we are using glass rod. Next one, watch glass. If we want to watch something, a reaction, we are using a watch glass like this. Okay. Next one, it is pipette. Okay, this is we use to, if we want to pour liquids drop by drop, we can use this one. You can see it is coming, water is coming out drop by drop. Okay, for that we can use pipette. Okay, so these are the common materials used in science lab. And the next one, it is spatula. If we want to take something, if we want to take some materials, it is barium chloride. If we want to take barium chloride from this, we can open the lid of this bottle and we can take, it's just like a spoon, we can take it out. Okay, then we can pour into the test tube or whatever it is. This is the use of spatula. It is used to mix also. Okay, these are the common materials used in chemistry lab. Now we are going to discuss one of the major reactions that is happening in our body also, that is neutralization reaction. Neutralization reaction means an acid is reacting with a base, produces salt and water. That means acid part won't be there, basic part won't be there, it will be neutral. That is why this is known as neutralization reaction. So now we can learn it with the help of an experiment. For that we have dilute HCl and dilute sodium hydroxide. Okay, dilute hydrochloric acid is reacting with the dilute sodium hydroxide, produces sodium chloride and water. That reaction is an example for a neutralization reaction. That we can take a test tube for doing the neutralization reaction. So for that I am using dilute sodium hydroxide. It is a base. Okay. So I am taking some amount of sodium hydroxide and I am adding some amount of phenolphthalein. It is a reagent which is called, so now it has changed its color. So in basic materials, phenolphthalein changes its color into pink. Okay, that is the indicator. So if we want to check a liquid whether it is acid or base, we can use an indicator, which is here we have used phenolphthalein solution for checking whether it is base or not. In basic materials or basic solutions, phenolphthalein will change its color into pink. Okay, and now I am going to add some amount of hydrochloric acid, dilute hydrochloric acid. Then we can see what will be going to happen. So when I have added HCl, dilute HCl, it has changed its color. That means neutralization has taken place. Okay, that is what neutralization reaction. Its importance in our stomach. In the last last class, we have discussed in digestive system, stomach produces hydrochloric acid. When the amount of hydrochloric acid is more, that time we feel stomach pain. To get rid of that, we are using milk of magnesia for neutralization. Okay, so that makes our stomach neither basic nor acidic. It makes neutralization is taking place and then we will get relief from our stomach ache. So that is neutralization reaction. So neutralization reaction is the reaction between a base and an acid forms neutral substances like salt and water. Next we can discuss about a reaction between a metal and an acid. For that we have zinc metal and a sulfuric acid. Now here you can see zinc metal. So it is silver in color. Okay, that metal is reacting with the dilute sulfuric acid. We have to take aqueous solution of sulfuric acid, then only which will react completely with the zinc. When zinc is reacting with the acid or any metal that is reacting with the dilute acid, you know acid contain hydrogen and zinc is more reactive than hydrogen, so which can liberate hydrogen gas. Now in this reaction, zinc is reacting with the dilute sulfuric acid, that means aqueous solution of sulfuric acid. Okay, here I am going to put this zinc metal into this acid. Okay, that time which is getting reacted with the acid and you can see now bubbles are coming out. That is liberation of hydrogen gas. So gas is coming out. So here in this bottom part of this test tube, you can see inside the test tube, you can see that metal is covered with bubbles. That means which is reacting with the acid and bubbles, that is hydrogen gas. Hydrogen gas is liberating out. Okay, and such a reaction in a metal is reacting with the acid, produces hydrogen gas or liberates hydrogen gas along with the production of a salt, metal salt. Here zinc is reacting with the sulfuric acid, then we will get zinc sulfate with the liberation of hydrogen gas. Now we can discuss about another important reactions of metals. A metal is reacting with a salt solution. Here in this reaction, more reactive metal displaces less reactive metal from its salt solution, and such a reaction is known as displacement reaction. So that is, more reactive metals displace less reactive metals from its salt solution. And here we have two different materials, it is zinc and this blue colored powder which is a salt which is known as copper sulfate. Okay, we have two different materials, one it is zinc metal and the other one it is copper sulfate, it is powder. Okay, for the reaction we are taking aqueous solution. So mixing with the copper sulfate is mixing with the water, forming copper sulfate solution or aqueous solution of copper sulfate. And I am going to take some amount of copper sulfate in this test tube for doing the displacement reaction. Okay, and then to this copper sulfate solution I am going to put zinc metal. So you can observe the changes. Here in this case, zinc is more reactive than copper, so it can displace copper from copper sulfate solution and forms zinc sulfate and copper. Such a reaction is known as displacement reaction. Here you can see at the bottom of this test tube, copper has settled down. Okay, that is displacement of copper has taken place because of the presence of zinc. And it has happened after some time. Okay, so copper sulfate react with the zinc, produced zinc sulfate and copper. At the bottom of this test tube, brown colored copper is seen. Next experiment is double displacement reaction. Double displacement reaction means exchange of ions. Two salt solutions we are taking. Now we have barium chloride and sodium sulfate. Okay, barium chloride and sodium sulfate is reacting together to form barium sulfate and sodium chloride. So their exchange of ion is taking place. Such a reaction is known as double displacement reaction. So here we have solutions, aqueous solutions of barium chloride and sodium sulfate. Now I am going to mix this. You can see the change. Observe the change carefully and record in your book. So what happened when I have added sodium sulfate to barium chloride solution? It has changed its color. Now we can see it is settling down. That substance is settling down. That powder like structure is there, and that is called particles are moving down, that is called barium sulfate. This reaction is known as precipitation reaction. If we are keeping this for some time undisturbed, we will get precipitate at the bottom of this test tube, and such a reaction is known as precipitation reaction because we will get a precipitate at the bottom of the test tube, and this reaction is known as double displacement reaction. Children, so far we discussed about different kinds of chemical reactions. All these reactions we used in different field like medical industry and medical field, other industries and factories. They use different kinds of chemical reactions for the production of different materials. Many materials you are aware of the things, salt, common salt, sodium chloride, and medicines, different medicines that contain alcohol, and all those are prepared in laboratories and we are keeping in bottles like this. Some chemicals we cannot keep in white colored bottle like this, some are kept in brown colored bottles because some chemicals they react with the light, sunlight. Okay, that is why here you can see different colors of bottles. Okay, anyway, I hope you understood this class about the reactions, chemical reactions and all. More about the reactions you have learned in your theory classes, and I hope you enjoyed this video. Thank you and have a nice day.